Okay. So let's start with, I'm going to go over a couple slides from my postdoc mentor. Right, so my PhD advisor has a way of making figures, and they're pretty much the standard way that you see in most figures. And when I joined UCSB, Ram Seshadri's group at UCSB, he has like a very clear philosophy for making figures, which I've just completely latched on to. I think it's terrific. You're welcome to think differently, that's fine. But here's some of his opinions on it, on how to make nice figures for publications and presentations, right? And it goes back to some of the stuff that we talked about last time, that if you're going to spend all this effort and time, that you ought to make it worthwhile, right? You're going to spend on average, like per publication in grad school, it's probably a year of your life roughly that goes into it, maybe a little bit less. So if you spent all this time, and a year of your life means quite a bit of money, probably around 100 grand of total expenses went into something, you should really make all that money and time be worthwhile and make sure that your audience can understand it in the most simple way possible, which means just care about your data, care about how you're presenting it, and care about how people are going to interpret it based on how you prepared it, right? We mentioned last time we generate lots of data. We should try and make sure we're reading it nicely. So he actually gives opinions all the way from like font to like colors and sizing, and I'm just going to go through it, and you guys, I'm curious what your opinions are, if you agree or disagree. On fonts, one of the first things he gets to, he says there's generally two classes of fonts. There's obviously 10 billion different fonts out there, but they kind of fall into two classes that get used. You've got serif and sans serif, right? So you either have these little feet things at the bottom of the letters. Those are serifs, right? From some Latin word for feet or something, right? Is it? I don't know. Something like that, right? And then sans, I know, means without, right? So sans serif is something like Helvetica, Calibra, Arial, things that don't have that. So when do you use which one? You can use whatever you want, honestly. But in his opinion, I think I agree with him, that serif-free, so without these little bitty things, these work better for short blurbs, right, and presentations, right? But if you're going to read a long paragraph of text like in an article, it's nice to have little serifs because it gives you a bit of like a bottom line that your eye can follow a little bit more easily, right? So it's not that one's better than the other, it's just that they have different applications. For labeling, for presentations, short blurbs, this is fine. If you're going to write text, these tend to, I think, look a little bit easier, and they're easier to follow with your eye, right? Obviously, there's a lot of fonts which I hope you guys just never use in technical presentations, unless you're doing it as a, I don't know, if you have some good reason to want to use Comic Sans or some of these wingdings or whatever, and there's smirking going on the room, and yet this happens all the time. One of my good friends, Chet Boxley, who I love dearly, he led one of his students at a presentation with the program manager, used this like old-timey Wild West font that looked like it had like bullet holes in it. It's like, it just looks really unprofessional, right? So I don't recommend, I just care about what you're presenting. I realize how people are going to view it. There are some somewhat less formal fonts. He has Indica here, which is somewhere, it's still nice, but it's a little bit less formal. I don't care if I use that. Now let's talk about plots though, right? So plots, one of the biggest things I had to change when I went to his group is they all do square plots. And I was like, why do these square plots? My PhD advisor was big on the whole golden rule. You should have this roughly 3:5 ratio-ish, and it just looks nice to the eye, you would say. So Ram's group are big fans of square plots, but they do it for a specific reason. And the reason is that they shrink well, and most of the time your figures are getting shrunk, right? So here's an example of a good plot, and there's lots of good things to notice here. First off, you see that the size of the font everywhere is the exact same. So just yesterday in our 6011 class, we saw some good presentations, but a common thing is I'm sitting 2 rows back, and I have bad eyesight, but still, I can't read the fonts, right? Because it's small, and by the time you actually make it fit on your PowerPoint presentation or whatever, it's gotten even smaller. So making sure that anybody in the room or person holding the paper, whatever the format is where they're looking at your plot, can read everything that's on it is just critical. This is probably one of the most overlooked things, I think, in presenting data. I think all 3 groups that did it yesterday had a problem where you couldn't read data, and that's frustrating to the audience. They stopped listening to you, and they're trying to pay attention to the numbers on there. I had to ask multiple times for Christian, right, to what the numbers were.
QTgrace.
I did see that, but he didn't make them square, and he had crazy fonts. I don't think well, I'll show you this. You can change the default settings in QTgrace to have these all be the same, and I don't think that anybody sent him the default file yet. Anyways. So one thing is that you can read everything nicely. What else is nice about this? Talks about it here a little bit. Anything you guys notice though? You don't have to read this. I'm okay if you don't read this. I'd be happy with this comment. What about this plot is easy to interpret?
Suppose there's not too much about it.
Yeah, it's easy to overwhelm your audience and put like way too much data in one plot. You think because you collected data, it all should be shown. Sometimes if it doesn't go to the main point of why you're showing the figure, you can edit it out, right? We get really married to our data and the work we've done, and we don't want to let it go. Sometimes it's right to actually let it go, right? They've done 2 different colors. These are ones that print differently, even in grayscale. Somebody prints this in black and white, you'll be able to see the difference. But moreover, they made one a broken line and one a solid line, right? It's very clearly labeled which is which with the same indicators up here in the legend. This sounds trivial, right? But people don't do this all the time. The stroke is large enough that you can see it easily on this background. Yeah.
So this is a kind of a question about presenting data for a presentation versus in a paper.
Okay.
Is it okay to have more information about paper if they've got time to sit down and actually look at it?
So if you guys looked up Jean-Luc Dumont, one of the things he talks about is do not just pluck the figure from your paper and throw it into your PowerPoint, right, your presentation, because it's a different medium, right? A paper, you're intending the audience to read it, right, as opposed to you just talking about a few key concepts when you're presenting. He's a big fan of that. Another thing he does, or at least he suggests doing, is take this axis and rotate it so it's easier to read, things like that, and less information also when you present. So it can be a little bit more dense with information, but still, only add information that's really helping you tell the story that you want to tell with it, even in a publication. There's no need to add like every single scan if it muddies up the picture. You can delete a few of those scans out if it conveys information in a better way, right? The tick labels, the fact that they have tick labels on top and bottom make it really easy. If you did want to read a value off of here, you could do so. You could put a ruler on it and read a value off, right? The fact that they have major as well as minor tick marks and that the spacing is something reasonable. This all seems very simple. And Excel, for the most part, if you just use Excel, will get a lot of this kind of right, but it can get it very wrong, right? Yeah, that's what it's got there. So this is at 5 inches, for example. That separation here. But if you go to print this, more often than not, they get shrunk down, right? By the time you publish it, most journals have 2-column format, and because they pay per page, editors really try and shrink your article down, and your advisor might as well, because you pay per page, right, in most journals. So you actually want to condense it. So your figure, which was big and easy to read before, got shrunk, and you need to make sure that this is all still legible, right? For whatever your audience format is, whether it's presentation or on print. Yeah.
This square versus 5/3 thing, is that just the data box? Or is
I like the whole thing, but the data box is fine too. I break this rule sometimes, but it's something I try and adhere to. There's cases where it doesn't make sense. Remember I showed you guys last time one where I had like 4 different types of information all stacked on each other. That didn't lend itself particularly well to a totally square plot. But what you want to avoid is if you do like the wider, more wide than it is tall, which is sort of a standard size that Excel and many other things spit out, when you shrink that, this got really, really short, right? And the data gets really, really hard to see. It gets really, really small. So having a square plot forces it when it shrinks to give you more space to look at. So you don't have to do this. It's my suggestion. I've now completely adopted. People in my group all do it. I think it's just a better way to plot.
The tables a lot of times you take that both columns like at the top.
And you can request, right? You can request to the editor, like, this needs to be a 2-column figure, right? You can do that. And sometimes they'll disagree for some reason. You can bicker about it. Usually they'll do what you ask them, though, unless you're taking a lot of space. So what sort of colors should you use? There's no one right thing on colors. I peruse this every once in a while. You can Google, like, colors for scientific publication. There's lots and lots of blogs and articles that have talked about this. There's clever rules on how your eye interprets different gradients and hues as well as intensities. Like your eyes are interesting in how they interpret that, and people have tried to use the math of that to suggest different colors that are equal in terms of change, if that's what you're looking for. Generally speaking, I just say pick things that look nice, pick things that are easily that you can tell apart from one another, right? And then avoid things that are going to be distracting, right? They're presenting actually okay here. On my computer screen, this yellow is almost invisible, as is the green, and this is just obnoxiously bright. So think about how it's going to project, right? I had a really nice series of slides I put together when I went to Florida to give a talk, and then when it presented, the projector was garbage, and everything looked terrible, right? So be aware that what you see may not be in the final format. It's always great if you can get a peek ahead of time or try and realize how it's going to print. right? So colors, I'll show you some of the colors I like when we do the QTgrace demo in a minute. Okay, and so what are examples of a bad plot? If we can learn a lot by looking at a good plot, let's learn by looking at a bad plot too. This is the default plot from a software. Anybody use this software? Know where it's coming from? It's not MATLAB, like it. This is Maple. Maple's another math software that, at least when I was an undergrad, they were huge on. I don't know if you could use that much you want. But the default plot, when you say like, plot this function, plot that function from 0 to 9 or wherever they have it going, this is what it spits out, right? It's sort of this like 5x3 golden rule thing, right? Which is fine. The stroke on these, first off, they pick like this really thin stroke, and then it's red and green, which is completely the same if you're colorblind. Most folks have colorblind problems. That looks the exact same to them. These are tiny, this is big, this is like a big spacing, that's like a small spacing. It's just not great, right? But at least you can read it and mostly interpret it in this format. By the time you shrink this down to a 2-column format, it gets really, really hard, right? By the time you shrink that down, this is the exact same data plotted, one with care, and one just as the default that something like Excel or something might spit out, right? And it's just really hard to read the data, right? This stuff is now, this is what I was looking at yesterday in the presentations. Couldn't read these numbers, right? It makes me crazy. Whereas this, even though you've had to make it small, all the data is still interpretable, right? So, and again, by making it square, it gives you much more room to look at. Right? Okay, so there's thoughts on that. So what about insets? Insets are very common in scientific publications, but we have insets. And the most common way that people do this is they make 2 figures in Excel or whatever. They turn one into like an image file. They turn it into a ping or something. Then they drop it on top of the other one in PowerPoint and like shrink it down until like the white doesn't cover up your line written, right? They'll shrink it down until this isn't on top of that. And they're like, okay, we're done. So what's bad about that is that all this, by shrinking it down, became very, very difficult to read normally. Right? So again, if you're going to do insets, the same rules apply. Anything on your plot, I think as a general rule, all of your font size should be the exact same all the way through. Make everything the exact same font size, unless you really have a good reason for making something smaller, right? So instead of shrinking it down, actually find software that can plot this in that way. So your marker size here is the same as your marker size here. It doesn't have to look like it's been shrunk down to the side of it. So insets are one way to make it, right? You can make it work all right, but there's an even better way. By the way, notice the additional redundant information by doing circles versus squares, filled versus open, solid line versus broken line. Just making it as obvious as possible the difference between your data is helping them interpret it, right? But a better alternative to doing insets is to do multi-panel plots. If you remember the example I showed you yesterday where it was like 5 different types of data we collected, we made different panels, right? Different panels can be really useful, especially if they have a common axis. Here they don't have the same common axis. It's going from 4 to maybe 9, and here's going from 0 to 9. So it's not uncommon, but it's still a better way to show this because on one they can do a linear plot, on the other they can do linear log, right? So you can show the information a different way. So here, this is the same exact information as we previously saw, just that it's a little bit easier to interpret here than here as an inset, I think. Right? So one of the challenges is that Excel doesn't have a simple way to make multi-panel plots, right? So if you're using Excel as your go-to tool, it's not going to be easier. I don't even know if it's possible to do this. Maybe you can. I don't know if it's going to be easy though. Origin and other software can do this fine. I'm going to show you how to do it in QTgrace where it's very simple to do. Again, don't do it this way though. The common thing is to take a plot. Here's your regular plot, here's your other one, you just shrunk it down, now it's completely invisible what the meaning is in there. And this happens all the time. I've done this. My first paper in grad school, I think I did this. I took something from the literature, and instead of even gathering the data myself and replotting it, I just like screen captured it and like shrunk it on top of one of mine. And it's like very common to do this. It's just not useful to the readers. Which gets even worse by the time you shrink it to a 2-column format. It's terrible, right? Okay, plots from instruments. A lot of times the info we take comes from a spectrometer or from some instrument, and the older the instrument, the more likely it is that it, heaven forbid, it's only got a paper copy, but it might only have like an image that it spits out, and you may not even have access to the data you're looking for. If that's the case, you need to harvest that data using something like Plot Digitizer, Data Thief, which we had to use in one of the homeworks this semester, right? But this is an unfortunate but not an uncommon display that comes from an instrument. So what are the problems with this? first off, you have no tick marks, so you're left to kind of wonder where the actual marks appear. And with a plot like this spectroscopy, it's all about knowing the location of these peaks. And it's going to be very hard to read where that one's at, right? It's like, well, it's not 1,000, it's not 1,500, it's going the wrong way, that's common with spectroscopy. It's just hard, it's a hard to interpret plot, right? So adding even tick marks would be useful here. Another one is they've got these numbers here with no units next to them, so this must be arbitrary intensity, but your reader might be wondering what units these are, right? They've got this thing here, they've got a -1 next to it instead of an exponent. It's just sloppy and it's small and hard to read, right? So take this same data, harvest the data points, which you've learned how to do, it's not very hard, and then replot it yourself in an appropriate way. I'll show you an example in just a bit for spectroscopy.
I have a question.
Yep.
This one, if you had to use that data, would you just try to make some kind of estimate what tick marks should be, or would you like calibrate off a peak or something?
What would I do? I'd put it right in the middle of the phone numbers. That's probably what I'd do. It'd be better if you did have something where you know exactly a peak is at this position, then you could maybe do it that way. But realistically, I'd probably just put it right in the middle of those numbers. But it's subjective at that point, so it's not great. Right. What about microscopy? As material science in particular, a lot of, it's very common for every paper you write to have one or more images inside of it that are either optical or SEM microscopy. So what do we think about those? Well, a standard figure from a journal article might look like this. And you might think that's a pretty good image, right? I have no problem with that. So things to make it better, though, is you've got, what really matters on figures, the most important additional information you're going to add is the scale bar. People just want to know what the scale it's projected at, right? And depending on how it's shown, this scale bar is difficult to read. You notice this thing right here, that looks like 6 microns, but it's not easy to read. And then this other stuff, you see words, but you don't actually care about these words. They're just noise, basically. They're not part of what you're truly trying to show people. So something Ron really advises people do is take that, cut it out. Again, he makes it square, but cut it out, and then replot your own scale bar, right? Take that exact same image, make it square, draw your own little white rectangle on it, make sure it's the right size, and then write in very obvious font what the scale bar is. I've taken to adopting this. I think it makes any microscopy image just look a lot better. Okay, we've already talked about posters a little bit. So then he just gives a bunch of examples of nice figures. So this was from a guy named Nate George in the group. Oh, it's not from Maureen. Sorry, that was Nate George. So Maureen, she did temperature-dependent diffraction studies. So there's some coercivity measurements here, there's heat capacity, and there's diffraction. What they have in common, sort of the data I showed you from last time, is that they have the same x-axis here, temperature. They're showing something happening as a function of temperature. So they're clearly showing that something's occurring right here, and by lining those up, it makes it obvious. Something I like that they did is not only show you a heat map, which are nice for showing a lot of information in a two-dimensional format, but a heat map, they also took this end member of the heat map and this end member of the heat map and plotted those separately so you can see with a little bit more detail what's going on there, which is a nice touch. Overall, it's no longer square, but this is still going to shrink pretty well and show the information. Another one, this is from Nate, right? Similar thing, take a heat map, but show what the end members look like on either side of the heat map. He's not a fan of dark backgrounds when you present. I think I generally agree with him. In fact, you can take really important, astonishing even data, like the discovery of superconductivity, and when you plot it on a dark background, it can look terrible. So I don't care what you do, but be aware that just realize how it's going to look when you present it. And if you think it looks cool to have a dark background, make sure that your data is still easy to interpret, because that's the main part of it. Take a look at what he's done here with this multi-panel figure. Again, it's square overall. They've got microscopy images. They've cut out the parts you don't care about. They've added their own scale bars with the right color to make it distinguishable from whatever's behind it. In this case, black. In this case, white. Whatever makes it most easy to distinguish. I think I actually added a shadow behind this one to make it a little easier to see. They inset the selected area diffraction pattern on top of it. Overall, it's just a very nice, easy way to interpret this. They've shown you that you've got both half Heusler and the full Heusler phases present by labeling on top of the SEM image or the DEM image. Makes it a really nice and easy to interpret plot, right, if you have the paper to go along with it. If you're doing material science, often, very commonly, since one of the core tenets of material science is structure-property relationships, then you need to talk about the structure of materials. If you're a chemist or whatever else, you also might find yourself needing to talk about crystal structures. learn how to use some software, right? They're free. Like Vesta is the one that I use. That's what these were generated, is in Vesta. It's totally free to use. It's not that hard to learn. If you want to learn and you don't know how, come talk to me. I'll have you work with all my students. Really easy to learn. And you can make beautiful figures, right? Now when you're talking about the structure, maybe you're talking about the number of repeat perovskite units in the structure and how that changes the catalytic properties or whatever else that you're working on. You can illustrate it nicely with a figure that really shows it cleanly, right? You add this on, you say basically whatever you're trying to do. You point across. But learning how to do these is not hard to do, and you can make very nice crystal structures from them. Yeah. Okay, so that said, let me switch gears now in the remaining roughly half hour and show you how to use the plotting tool which I use, which is QTgrace. So QTgrace, you can find it by going to SourceForge and just typing QTgrace. SourceForge. And it just updated, so it's actually a brand new version that came out in February. It's got like undo and stuff. Before the old one you couldn't undo.
It tells you, like, it'll pop up with, you have multiple data sets, which one's which one.
Oh, that's really nice. Yeah. I actually am not using it yet because I've been too lazy, but I did download it and try it. So it's free. You can download it right here. I strongly recommend it. You don't have to for anything in this class or anything. I just recommend you learn it. That said, how does it actually work, right? So let's come here. Like, let's say you've got all this data, right? You want to plot it. And this is just the Excel version of some spectroscopy data. So you would grab it and you need to go to a 2-column format, right? So what I do is I open up Notepad, right? You take the data that you want to plot. Let's say it's this data, right? You're going to go all the way down, grab it. Oh, go to your Notepad. You have to paste it. You go Save As. The key thing to use QTgrace is you have to save them as .dat files, .dat files. So you can put this wherever you want. I'll just put it in my downloads for now. Test.dat. Right? So now that I have that, I can open up my QTgrace. And again, because I've changed the default parameters on my QTgrace, it automatically goes to a square format, which is something I prefer. And also, if you look at like the colors available, it's got predefined colors. You can make these be whatever you want. It's got like the font size. You can just change it to be exactly what you want it to be with the default. If anybody wants this, I'll send you our default file for the Sparks group. You're welcome to use it. That said, how do you import your data? You go to Data, Import. I'm told you can do it straight from a CSV file like in Excel. I never bother. I always just turn it into a .dat file. So you go to ASCII. You have to tell it where that thing's located. So I'm going to tell it, all right, look in my downloads folder. And sure enough, there's test.dat. So from here, you just double click it, and it's going to column count incorrect. Did I mess something up? Oh, my bad. All right, let me delete out the first row. Of course, this happens on a demo. Yeah, I'm just going to delete it. If you put a hashtag in front, it ignores it. All right, let me redo that. Okay, it's telling me it skipped something for some reason on the very last row. I think I needed to put an extra delete at the very end. But there's my data, right? So once you do this, you can import multiple data sets, right? You can do this one at a time, or I recently learned that you can actually import multiple data sets in an easier way. All right, so I'll show you what I mean. Let me just hide this for a moment. Right, so if I want to import more data, I'm going to go to where I have it at, which is synthesis here. Normally you have to tell it, are you importing a single set of data or N, X, Y, or block, right? What's interesting is that if you tell it single set of data and you still tell it to import, it'll still break it up into a bunch of different data sets. So it automatically recognized that that contained like 12 different data sets. So how did I tell it that it had 12 different data sets? All I had to do was come over to that folder I was working out of, and if I open up this data file in Notepad, you can see all I did was I added the little ampersand sign, right? So here's the hashtag, the pound sign, I guess, with the name of this first set of data, whatever you want to call it, right? But when I put this ampersand with whatever else, that's telling it that a new data set is coming, right? So it actually is going to incorporate all 11 or 12 of these data sets automatically, right? And it automatically will start to assign them colors based off of the order that you have colors here, right? The very first color it's going to assign the first data set is black, followed by the sun ray, Neptune, pumpkin, clover, and right. Just go down, and you can set this to be whatever you want. This is totally user determined. You tell it the RGB value for whatever colors you want, right? Again, I can send you our default file that has these on it, or you can make your own. It's no problem, right? This I took from one of these articles of blogs that talked about how your eye interprets different hues and color that have like monotonic changes. Included those as well as what my postdoc required all this to print in. And these just tend to be kind of nice colors. Yeah.
Is this importing the series name to like a column name?
I know you can make it do that. I think on the new QTgrace it does. This doesn't automatically. No. So you still have to type in the names of these things, right? So this takes a little bit more work than Excel, but the final product is just a lot nicer, right? So let me pull up an example of like that spectroscopy data, right? So if I go back to our, let's see, under research Fisher. So if I go to one of like our figures. So I don't know which one. I've made a few here. Let's pull them up, see what they look like. You can take the actual data. You can make the marker size and whatever else be exactly whatever you want. Just like in Excel you can. It's just a little bit simpler to, I think, to do here. But one of the most powerful things about this is that you can easily export it to something like Illustrator, right? So let's say I want to, the vertical axis doesn't necessarily matter here. I should be able to shift these and I should show a trend. It's difficult to do in a plot software like this because you have to actually change the data. It's nice if you can send it to Excel, or Illustrator I mean, and manually move it around. So how do you do that? You'd come over here to File. You're going to export it, but you're not going to export it as a ping, so you have to change how it's going to export. Tell it you want to export it as an EPS or an SVG. Either of those are vector graphics, meaning that Illustrator can open them and move them around. So if you have a bunch of diffraction data, it's all on top of each other, and you want to separate it out so it's easier to interpret, it becomes really easy to do, right? Tell it to send it as an EPS, then just export it, right? From that point, it says, oh, there's already one in there. Do you want me to replace it? So last time I did this, I created one. But basically, I can take that, DSC zoom, and now it's an EPS file. So this thing will open in Illustrator automatically. After a few moments. By the way, as students, you guys have access to Illustrator and the Adobe products. I strongly recommend learning how to use them now. It's free to have access to them, so learn now and then buy them when you go out and get jobs, right? Because it's tremendously powerful software. As I mentioned, one of the things you might want to do is move these things around vertically to get them in the right spot. Still loading. This is tricky to do without a mouse. I'll try. So first off, it's telling me, hey, I don't have this font that you were using in QTgrace, so it's going to highlight those in pink. We can ignore that for a moment. We can change it if we want. But if you wanted to move these around, like to make them in order, all you'd have to do is just select one of these things. You come up here to select, you do select all with the same appearance. It's going to take everything that has the same color, same stroke, whatever. It's going to grab them all together, and then you can really easily move these wherever you want them to go, right? Which is really nice. So using that approach, you can make figures that look like, take that same data, which is harder to interpret, and if you spend a little bit of time making it easier for your audience to interpret, you can make it look like, I think I've done it in here. Maybe. Too much happening in my poor computer. I'll close some of these. Yeah, Christian?
So with that particular data set, you have a y-axis, but you're moving your stuff around.
Yeah, it's the relative change. So you'd have to change your values here and basically say, well, you have to inform them that it's been moved, right? That's not the raw value. With DSC, if it has if it's been normalized to 0 anyways, then it won't matter. So yeah, anytime, this is like a broader, more general topic is it okay to move your data around, right? It's not okay to falsify your data, right? But is it okay to take how about this one? Let me go to Fisher. Let's see, FTIR. I think this is the one. Yeah, right here. So in this case, when it came out of the Excel, right, the raw data, if you throw it up in Excel, this stuff's all right on top of each other, and it's very hard to tell apart. So is it acceptable to move it up and down? It is, but you need to tell them that you've changed your units, right? And then what I'm really trying to tell them is like, hey, just look at the relative change. Obviously, this represents the baseline, and this would be the same as that up there, but the relative change is what you're being able to see more easily here. And you're able to line up key features, right? This is some bond, this is a different bond, this is a different bond. So being able to take something and plot it in whatever software you want, like QTgrace, and then turn it into an Illustrator file where you move them around, where you do subsequent labeling, is just a very powerful tool. This is what your editors do for any science nature, like these really, really high visibility journals, is they employ people to replot your data, right? If you're going to submit to the American Chemical Society or Ceramic Society, you're going to have to do this yourself if you want it to look as nice. And so learning how to do it is worth your time, I think. Because you can make just very nice figures. It's much more easy to talk about, these different bonds that are happening in your material when you take the time to show the data in a clear way. Yeah, Christian?
Is there anything where you can do when that y-axis is actually really important? For example, transmittance for because if you were to move them around, and you're only looking for maximum values, it kind of takes away.
It does. You could make a multi-panel is probably your best bet. So again, you would go to, what if I wanted to break this data up and show it in two different panels, right? How do we do that? Well, to do that in QTgrace, it's not so hard. You come up here to data, and you're going to go to, I think it's plot. No, graph. You're going to go to plot and then go to graph, right? Right now, all the graph is sitting, it exists in what we call this global graph, G0. So this whole space is right now called G0. That's what this plot is. So first thing we want to do is we want to duplicate that. So there's two of those plots, and then we're going to move them relative to one another, right? So you can just right-click on it and duplicate. So now you have two data sets, and they're sitting on the exact same spot, so it doesn't look any different. But then what you can do is you can take, all right, G1, that's going to be the upper inset, right? So that's going to go, I'm going to plot it not starting at 0.2 in the y-axis, right? Because this whole space goes from like 0 to 1 in both x and y. So this graph starts at 0.2 and ends at 0.8, same with 0.2 to 0.8. We're going to change that. We're going to make one of our graphs start at just above half and one end at just below half. So that's simple to do. We're going to change y. Instead of starting at 0.2 for this one, let's have it start at like 0.52, right? So now it looks a little bit messy, but we can take this one and tell it to start at 0.2 and end at 0.48, for example. And you've got a pretty nice multi-panel plot. You can do this as many times as you want, adding more and more data in whatever way makes sense, right? You can turn off these labels since they are plotted on the same tick marks. You can actually shrink that gap a little bit and just get the text out and make it obvious to the viewer what they're looking at. This is all, it all can be controlled in a much more controlled fashion than in something like Excel where you have to I don't even think you can plot multi-panel, and even if you did, I think it'd be really challenging. Because mostly it's done by eye. Here you can tell the exact coordinates so things line up just right. You could make like an image that has like one big panel here and a bunch of smaller ones here. You could have those separated in a very easy way just by controlling where your X and Y start for each plot, right? You can turn data on and off in each of these sets now. Let's say you only wanted to show some of the data up here. So it's just a matter of double clicking it, and you could hide some of the data sets. Right? You'd hide whatever ones you made sense to hide. Over here, now you double click on this data set and you could hide different data here, right? So whatever made sense to show it would probably be the way to go, Christian. Otherwise, you'd have to say relative and transparency or something like that in your plot. And as long as you're not being dishonest in the data you show, it's fair game. Whatever you do to make it clear for the viewer is fair game. You just can't falsify data. You can't make it look like something it isn't, right? Yeah, Garrett?
Could you overlay or superimpose images into this?
Absolutely. Oh, in QTgrace? No, but you can leave an empty spot and then do that in Illustrator. That's where I'd do it for sure. QTgrace is great for getting axes, right? Like controlling like your tick marks, getting data roughly where it ought to be. And then I do my final edits all in Illustrator, and that's really easy to do. You can just copy and paste an image and drop it right on top of it. It's really easy. So with the paper that we wrote in Untitled Chapter, that's how I made those, was all in Illustrator. So you can have your diffraction pattern. You can have, if you want to show like a microstructure on top of it or something, it'd be really easy to overlay it on top of it. Okay. Let's see, we've got 15 minutes left. What else is useful to cover, Emily, with QTgrace or Christian? Let's talk about moving the legend, right? When you first make data, the legend is right here in the middle. Right now you see that our legend is actually overlapping on both of these. So you can move the legend around by going up to plot and graph appearance. And there's all these different tabs. Like if you want to have a title on your plot, I don't think you should ever have a title on your plot, but if you want to have one, you could change it right here. And then like the legends and legend box, you can change. And again, it's located in terms of coordinates, right? So if you want this one to be at a different height, like starting at, X should be 8.85. But if you want it to start at a different height, you can make it start at like 0.4 or something, right? And it would move it relative to it. Oh, 0.85. I'm about to say, where to go? Right, and then it'd be down here. Again, this might be easier to do just in Illustrator once you're done. So if it's on the exact spot where you want it, it's very easy to move it where you want it to in Illustrator, because these can just be grabbed, right? If you come over here to, once you've exported as an EPS or a SVG, you can just grab this stuff and just move it wherever you want, right? Wherever it makes sense to move it. You can force things to line up. This is much easier with a mouse. You can make things line up. So let's group them first. I'm going to group these two things. So now these are as a group, meaning they're going to take actions as a group rather than individuals. Then you can take these and using these alignment tools, you could align them centered, or maybe you want like the data points to line up. You can do a left align so that then they line up exactly to whatever you want on the side of this plot. So all this is just much more accurate and precise and looks better than if you try and do it by hand in Excel or whatever tools you're using. Yeah. So that's good. I guess the only downside is I like to be able to have it be at a specific site so it lines up perfectly. You don't have to worry about doing it by mouse. Oh, perfect. Okay. That's nice. Okay, what else is useful? Usually we run out of time on here. Here about 10 extra minutes. I'm surprised. What am I forgetting to show you guys? Excellent point. Let's say that your data, you want to fit some sort of line to it. Let me pull up another plot where we've already done it. So if you want to fit data to it, in Excel you've got like 5 or 6 options, and none of them are really very good nonlinear options. You've got like a power and an exponential, but it's pretty limited. If you've got, as you will in grad school, some sort of equation that you want to fit your data to, like take like your hardness data, right? How would you fit that line of hardness as a function of composition to your data? Excel, you wouldn't be able to. You need a custom expression to fit it. QTgrace is really easy to fit custom expressions. So we'll just go to the electrochrome. So take, for example, the Avrami equation. Oh, not this one. Let me go to the raw data for it. Yeah, something like this. This data can be fit with the Avrami equation. So if you've taken a kinetics course, hopefully they talked about Avrami kinetics, which basically says it's flat, and then it starts to incrementally change, and then it's going to slowly asymptote and stop as it reaches some sort of transformation. So it goes from 0% transformed all the way up to 1, meaning 100% transformed, right? So how do you fit something like that? None of your Excel options are going to work, right? So to make it fit, it's really nice in QTgrace. You can define custom things. You're going to go up here to data, probably? Yeah, data transformations. And then you've got lots of options for regressions, right? We're going to do a nonlinear curve fitting. And in this case, I've already done it, so... Oh, it doesn't show it, though. It doesn't keep it. That surprises me. But you could write whatever you want, right? If you want whatever expression you want. So Avrami equation is y equals 1 minus exp exponential of a0, that's one constant, times x times, or raised to the a1, for example. Oops. Right? You can do that, no problem. I think it's supposed to be negative. Right? So you tell it, hey, I've got 2 parameters. A, that's A0, A0. I might have to make these capitalized, I don't remember. You can give them starting points with your regression, and it'll do a much better job if you give it a good starting point. All right, if I try it right now, it might fail. Like, what does it give me? Yeah, my R squared is like, actually not terrible. 0.96. Correlation coefficient, that's your R squared value. 0.96 is actually not very bad. So it found it okay on the first one. But it's really easy to do these fittings for any custom equation that you want to come up with multi-parameters, right? So again, if your research group pays for you guys to have origin or whatever, and you're already making nice figures, this could be a waste of time. But I find that most grad students don't have a free and customizable way to make nice figures and custom regressions. And this is at least one option for you guys to consider. It's really not so bad to use. What else is useful to cover here? Just we need to talk about.
Does that show the?
What it does is it creates a new line. Yeah, right. So it's basically, there's this whole source destination thing above it. When you do that, it took the data from here and it sent it to a new destination. So whatever was in there, it just got rewritten with the data points with that line. So then you can change that line independently. You'd come here and just like any of your data sets, like if you look at these, the symbol property that says none, there's no symbols. It's all just a line and the line's straight. So if you change this like left stairs, whatever that is, you'll see one of those got changed. I don't know which one it was, right? It might be easier just to change the color. We'll do straight and we'll make it turn something ridiculous like magenta, right? So it made that one right there change. But if you wanted to actually, it did assign values. You can make the values appear, but since it's a regression, it probably makes sense to not show it with values, markers, and just show it with a fitted line, right? So very easy tool for doing that. Pick whatever colors or fonts or however you want it. You can make these really easily into linear versus log or whatever. You just double click on the axis, or you could go up here to plot and go to axis properties. You can choose between linear, logarithmic, reciprocal, right? A lot of times material science, things are thermally activated, so we plot them as 1/t. This is a really simple way to do that. You can have multiple axes, right? You could have one showing real temperature, and then you have your reciprocal axis on the top one to make it just easier to interpret. This is the best tool for doing that. It's just way easier than trying to wing it by hand and draw those in Paint or PowerPoint or whatever abomination people do, right? This is the way to go for sure. Other stuff? Other questions? Does this interpolate? I'm sure it does. I've never used that function. I've never done the interpolation. Oh yeah, it says it does it. I've not used that before. So for what it's worth, it's there. This is, if you ever want to learn more about QTgrace, you can't figure out how to do something, it comes from a software in Linux, that's why it's freely available, called XMGrace. So if you Google XMGrace, it tells you how to do everything, and that's where you can learn how to use QTgrace. Special characters. So the new QTgrace is far better for that. Like let's say for your axis that you needed this to be like beta or something. There is a terminology for making that say beta, and in the old version of QTgrace it was so complicated that I never do it. I just export this I just write beta there, and in Illustrator I turn it into the beta symbol very, very easily. In the new QTgrace it uses LaTeX nomenclature, right? So anybody use LaTeX in here? 1, 2 people. LaTeX it's another way of writing documents. Don't learn how if you haven't learned already. If your advisor's not making you, I don't know if it's worth you doing. But you can the new QTgrace accepts LaTeX notation here. So you can put your number sign, you can write /beta, and it will create a beta symbol. The old QTgrace won't do that, the new one will. I've done it before, and then I realized like it was taking me more time to try and make it look right here than it was worth because it's so easy. Once I export it here, if I want this to be like an alpha for whatever reason, then I just change it to symbol. Huh? There it goes. Right, and you have an alpha. Like it couldn't be easier. Right? It's way better than trying to do it another way. Right? What else? What else is useful with figures? Anybody have challenges with figures that they don't like something that makes it hard? How about this? Another common thing with X-ray diffraction, we've only got a few minutes left, let me show it. I don't have it up yet. Or, no, I'm trying to think where I have one plotted. Close some things. Computers cannot handle all this stuff open. So let's go to Scholar, Ram Seshadri, diffraction. When you show X-ray diffraction patterns, it's useful to do the following. Synthesis, hopefully this will have a... This is harder than it should be. Let's go to Scholar. This one should have it. How would you make a figure like the one they have here? Don't be a paywall. With diffraction, hopefully it has it. Yeah, perfect. It's oftentimes really nice when you show diffraction data to show where you expect peaks to be. So in GSAS, you remember we did this, right? GSAS created, basically it showed you tick marks from where you expect the phases to be. That can be very useful for interpreting where data is that you expect, whereas as opposed to an impurity. So this was created in QTgrace. So what are their steps here? How would you go about making this? Here they've got multiple data sets. They've got the raw data. They've got a fit to the data. The fit to the data you want to connect to the line that don't have markers. The raw data you always show with markers. That's convention anyways. You should always show the markers for your actual raw data. They've got the difference between these two. If you take blue minus yellow at any given point, it's the background curve. So you can do a line there. It's not actual raw data, it's processed data, right? They've done the same thing for some other data set. And then they've got that line up there showing where all your peaks are at. So how do you generate that one? In QTgrace, it's called a, so you go to import data. And instead of interpreting it as XY data, you tell it that it is a bar, right? And now it's just going to take, it's only going to look for one value. Does it look for two? I've done it in a while. You might need to give it two. One is the X position, one is how high you want the bar to be. I think it is still a two value, right? But you can send that, and then what he's done to make that nice figure, he's brought it in as a bar, so you've got lines at every single point. And then for the y-axis, he just shrunk it down to some small thing. He didn't put any ticks or labels on it, and made sure that the bar value was larger than the value there, right? So you can indicate exactly where things are at. Again, this all does take more time and effort than just Excel, but the product is something a lot nicer than just Excel. These look like really well done plots that show you care about your audience, and it makes it easy to interpret whatever you're trying to show. Like take, for example here, this is X-ray and neutron of the same sample. X-ray and neutron are rarely, if ever, going to get the same wavelength, right? So when you go from like 10 to 90, it's totally different things. Going from 10 degrees to 9 degrees if you don't have the same wavelength are going to look like two totally different plots. But here he's chosen to plot it in Q space, in reciprocal space, right? And by doing that, they line up exactly because this has to do with where the crystal structure is at. So you can tell that there's some difference in the structure because he's made them line up nicely. Whereas most people would just plot these both from 10 to 90 or whatever they plotted without really caring about how easy or not it is to interpret your data. This is just a much better way to do it. Okay, any other questions people have on nice figures, how to make figures, questions on Illustrator, QTgrace, anything? This was a lot to go through. If you think that you even might be kind of interested in using this, but you need help in the future, swing by my office. If I happen to be busy, I'll put you in touch with Marcus or Christian or somebody who's quite good at this, and there's no reason not to learn how if you're interested in learning how to make nice figures. Okay, that's it for today then.